This show really started by trying to find a way to use coral rock for art and furniture without actually using coral rock. My wife Sarah and I just finished our home. We've been building a home for the past 5 years, and we did a coral rock retaining wall in the front of the house to reference some of these older buildings in the Grove and Coral Gables that have coral rock walls. A lot of those came about from using the rock that was removed to do the foundation for the home. So you start a new construction project, you dig out your foundation, your pilings, your footers, or whatever, and then you use that rock to do the wall around your house. So we did that. We used a lot of the rock on our site, but also from other construction sites too. And then it led me to really want to figure out how I could use this in my work, and very quickly determined that it made sense to use coral rock if you're getting it from your own site, but for furniture or other applications, it didn't really make sense to me to harvest it from the ground, because it's basically the bedrock of Miami. It filters our drinking water, it holds all of our drinking water, and once you remove it, you can't really, it leaves a void in the ground, you can't really put it back. So I immediately started looking for other ways to kind of synthesize my own coral in a way that could be all the things that coral isn't. So strong, lightweight, not brittle, and a way that could be more sustainable in terms of producing objects with it. So I started out by making furniture for the house, so benches and bookshelves and things like that, and testing it. It's all made out of EPS foam that has a hard shell coating, and then embedded with actual pieces of coral rock and natural elements. And since I'm making coral from scratch, I put in found objects of everyday objects that you might lose when you're swimming at the beach that could become fossils years later. The coral rock under Miami was from a coral reef that was about 150,000 years old. I think we'll talk about that in a minute, but that's my understanding. And so I was really drawn to these places in Miami that use coral rock, and places like the Venetian Pool, where they were coral rock quarries. It was a coral rock quarry when they dug up the rock and filled up with water, and they made it into a swimming pool modeled after Venice. So it became this kind of fantasy landscape from this really utilitarian beginning. And in like classic Miami fashion, it's this totally invented fantasy. So in doing this project, I wanted to reference places like the Venetian Pool or the Coral Castle, where they had this one origin, and then the fantasy kind of took over, and that's where the inspiration for the grotto comes from. I wanted to create my own kind of Mediterranean grotto using the faux coral rock. And I've always been interested in this, like in Biscaya, places like that are kind of show Miami's obsession with the Italian Renaissance, and kind of play off that a little bit. I think it's funny that now in the design district, it wasn't really planned, but I'm in between Versace and Pucci, and Balenciaga is taking over next. So it's like perfect full circle obsession with Italian material culture. So yeah, that's kind of the basis of the show. I think a lot of us know each other pretty well. So if anybody has questions during our talk, I think feel free to shout them out. But yeah, in talking about using coral rock, sustainability, what does that mean? Taking it out of the ground, removing this ancient fossil, clearly wasn't the right thing to do. This material is an EPS foam that's used in construction a lot, and basically comes from fossil fuels, or from petrochemicals. So it also has a lot of environmental implications. So kind of having these conversations, we thought about Shane and his work studying ocean currents, and asked him to kind of open up that conversation and talk. I guess coral isn't your specialty, but it comes into your line of work a lot.
Well, yeah. So a little disclaimer: I'm not a coral scientist, right? As Claire said, I'm a physical oceanographer, and being an oceanographer means a lot of things. And but you can be a biological oceanographer. You can study the biology of the ocean. You can be a chemical oceanographer. You can do chemistry, or you can be a physical oceanographer, meaning that you study the direction of the currents, sea level, the temperature, the salinity, etc., etc. But yeah, no. So, and of course, when you're interested in ocean physics, it's because we're interested in like the natural environment, and there's a lot of interaction between biology and physics, of course, and there's a lot of interaction with corals, with the state of the ocean. You've heard that corals are suffering from like increasing temperature in the ocean, etc., etc. And so, what sets the temperature of the ocean? It's like set by the currents, and so there's a lot of interaction. And if you think about, I think it's very interesting because if you think about the climate, the climate system that we live in, what is climate? It has like 4 components. It basically has the atmosphere, it has the ocean, it has the biosphere, which is basically all the living things in the ocean or on land or in the air. And the 4th one is what we call the cryosphere, which is all the solid water everywhere, like around Greenland or like at the top of glaciers in mountains and etc., etc. But the fact that we call it a climate system really means that there's an interaction between all these components, especially between the biology and the physics in the ocean. So like this, so the corals, as you said, that we find in Miami, the coral rock, the oolite, rock that we are basically sitting on here with that Atlantic coastal ridge, which is that region like where Miami has been built. I was reading about it as we were preparing this talk, and I found it very interesting to realize that the formation of that specific type of rock, that oolite that is embedding the coral, is actually very much due to the nature of the currents that, about 100,000 years ago, were actually flowing onto the coral reef. So actually, if you think about the oolite, that material that embeds the coral, it's actually formed little beads, right? So it starts with maybe a little grain of sand, and then it gets basically rolled back and forth by the currents. And as it rolls back and forth, it accumulates sediments, it accumulates all the calcium that forms the rock. It's a sedimentary rock. And the way these things can happen is that if you are in a very shallow area, such as a coral reef, which the Atlantic coastal ridge used to be about 100,000 years ago, and which are like a sandbar and like shoals, and basically you have tidal currents that are going to flow into one direction during the day and then another direction 12 hours later, and so you can imagine these currents are rolling back and forth over those grains of sand, and this is actually how oolite was formed. And it's very different from, let's say, if you go more inland toward the west, where you have a different type of rock, a different type of limestone, where in that instance, you didn't have that process of like, that coral reef that was shallower. You didn't have that process of back and forth of the currents, and you had a very different type of geological process that formed the rock.
Yeah, that was one. In doing this show and in working with coral rock, I was trying to figure out the origins of a lot of the words that are used to describe it, because you have a lot of different things being thrown around, like oolite, limestone, coral rock, keystone, and they all kind of get used interchangeably. So,
but they all have something in common, which is, to me, it's still mind-blowing. If you think about any type of limestone, oolite, basically what forms the entirety of the Florida Peninsula, where does that come from? It's calcite, it's like calcium carbonate, so it's like calcium, carbon, and oxygen that form that molecule. And those molecules came from the skeleton of marine animals. And so all these animals that used to live at the surface of the ocean, they have a short span, time life, and then they eventually die. and their skeletons, just like the skeleton of the corals, they die and then they basically precipitate. They fall to the bottom of the ocean, and as millennia goes on, they basically pile up, and then they become more and more compressed, and this is what is basically forming, limestone and rocks. So if you had a coral reef that used to be, much higher up, and then suddenly it becomes the sea level increases, and then suddenly it gets compacted, and it gets embedded into the formation of these rocks. So to me, it's still mind-blowing to think about all these animals that basically created those skeletons of calcium, and then became those rocks that millennia later, millions of years later, we used to be at home, or we used to be.
Yeah. One thing I've always, in doing this research, one thing that I thought was really interesting was, if you look at this map of the Atlantic coastal ridge, it perfectly mirrors where the development is.
Yeah.
So basically, like, the ridge is east of I-95 in Miami, and it kind of lines up with Brickell and downtown, and then extends it all the way up to Fort Lauderdale. So the map of ancient coral reef perfectly reflects the buildings that are going up, growing like coral. And one place where you can see it is at the Brickell Metro Rail station. There's a big exposed coral rock wall, and it's like 20 feet below the Metro Rail, which I always thought was kind of cool, because coral can only grow to a certain depth because it has to have light. So when you're riding the Metro Rail, you're kind of where sea level would have been however many years ago. So it's almost like you're at the Metro Rail height is at the ocean surface.
Yeah, so about 100,000 years ago, the sea level used to be 6 to 7 meters higher than it is nowadays, right? So in the last 2.5 million years, the Earth has been going through a cycle of glacial stages and interglacial stages, right? So all that water could be either trapped as ice over Greenland or Antarctica, or it's melted into the ocean. And as we went through through these natural cycles, the sea level has been going up and down at different levels. And so 100,000 years ago, 130,000 years ago, the sea level used to be much higher, and that Atlantic coastal ridge used to be shallows, used to be a sandbank, like Miami Beach is right now. And so at that time, this is when those corals started to grow. They attached themselves to those rocks, to those shallows, and they started to grow and form coral reef. And it's funny because I was reading that they grow between about 3 millimeters per year in terms of height. And so now the buildings have taken over. They continue to grow.
Yeah, it'd be interesting to know how much they grow every year.
Yeah, so it's about between 3 and 10 millimeters per year. I think that's what I remember.
I mean the skyscraper.
Oh, the skyscrapers. Sorry. Actually, I don't know.
So when we were talking before, you mentioned core samples and how you're not like a geologist, but one of the ways that they get information about ancient sea life, or even currents or ocean temperatures, was by taking core samples of coral.
Yeah, exactly. So, so one of the crazy things about corals is that they need to form their skeleton, right, and they grow. And so by growing their skeleton, they need to form that molecule of calcium carbonate. And so they need to they basically take CO2, which has 2 atoms of oxygen, and then they need to get an extra atom of oxygen, and they get it from water, H2O. Right? So those calcium carbonate inside that form the skeleton of the coral basically get a signature of the water that was in the surrounding at the time that it was growing, right? So it's still mind-blowing to me, but what happens is that what we call paleoclimatologists, people that study ancient climate, so they go to coral reefs, and they have licenses to do that, they're allowed to do that, and they actually take a core of the coral rocks of what basically the dead coral that is below the living coral, and then they take it back to the lab, And then they look at the isotopic composition of those molecules, right? So they're able to say, actually, they're able to say how many neutrons are actually inside the atom of oxygen. And how many neutrons are actually inside the atom of oxygen is a way of inferring what the temperature is to be in the ocean. Right? So they take that little core and they look at the chemical composition of the oxygen in those pores, and then they take those measurements at every millimeter along that core, and that basically give you a graph of what the temperature of the ocean used to be. So when I was a graduate student at the University of California, she was not a classmate of mine, but she was a friend of mine, an acquaintance. And she spent her PhD years basically diving in coral reef in the tropical Pacific. And then what she did exactly that. She reconstructed a time series of the temperature of the ocean there in the Pacific, and then she looked at the history of El Nino. So you may have heard of El Nino, which is that climate phenomena that happens about 4 to 7 years, and it influences the temperature of the water in the Pacific. So she looked at that report from the coral, and she was able to look at the frequency of El Nino in the past 1,000 years. And she was able to deduce how much El Nino was changing. Because one of the things we're trying to understand is that El Nino is a natural phenomenon, but we don't know, maybe it's going to become more frequent with climate change. And it affects everybody on the planet, like it affects us in Miami, even if it's happening in the Pacific. So we can actually use those corals as marker of past climates, which I think is an amazing thing to do.
Cool. And how? I mean, I guess my question would be, how do you take that information and think towards the next 100 years? Like what can that information tell you about what we need to do?
So one of the things that we do is we try to predict what the future climate is going to be, right? So just like you look at the weather forecast in the morning, it's a prediction of what the weather is going to be in a couple of days. So we're trying to do the same type of things, but for 100 years. So in order to be able to predict, we need to be able to understand the physics and the biology. We need to put that into equations, and we need to type these equations into a computer code, and we need to crank the wheels of a computer in order to predict what is going to happen in 100 years. So in order to be able to do that the best we can, we need to know what these equations are. Mm-hmm. So the way to do that is by looking at what happened in the past and trying to understand, how El Nino is, let's say, changing with different temperature. And then maybe we can code that into an equation that we're going to use for prediction for the future. Does that make sense? Mm-hmm. So that's how we use it. So one of the things we try to understand also is how currents are changing. Are they likely to become stronger or weaker with climate change? How much is the sea level going to change? How is that going to affect the currents? How is that going to change our natural environment? How is that going to change the growth of the coral? Because we have different patterns of currents, etc., etc. Mm-hmm. And so the reason why coral reefs are so important is because even if they have a very small footprint at the surface of the Earth, because they exist within the tropical band, right, where we are located, between 30 degrees north and 30 degrees south. And so if you look at the area of those coral reef, it's very small compared to the total area of the ocean, but they are such a teeming source of life that they are the base of ecosystems of like fish that we use to feed ourselves. So if the coral reefs actually die, then it's not a very good thing for like all the biology in the ocean.
Yeah, everything's interconnected.
Exactly.
So can I get in with? I'd love to ask you. So the relationship of coral rock to the way in which things are built here in Miami is a very strong one. I think a lot of people rely on oolite rock different kinds of rock because they are incredibly absorbent. And as we know, we live in an incredibly humid and wet place. When one excavates these rocks and kind of old reefs, what kind of an impact does that have on the Earth? And is this something that we should be doing, shouldn't be doing? I know, Emmett, you have quite strong views about this and based on the fact that you've created almost like an artificial reef here.
I think that's a good question. I know that areas in the aquifer where they're pumping water out, like a Turkey Point, it creates voids that then sucks salt water into the rock that's there. And I imagine the same sort of thing happens removing quarrying coral rock too. It creates a negative space that has to get filled with water, basically. One of the reasons why, the reason why salt water isn't just like coming up from the ground all over Florida is something called positive pressure. So the water that's in the aquifer, that rainwater and water flowing from the north, creates positive pressure outward, so the ocean water doesn't come in. So not having rock to hold that water, or some kind of like foundation, bedrock, would have a negative effect on that, I would imagine.
Yeah, because that pressure that you're talking about, as the sea level is rising, what does that mean? It means you're just piling up more water, right? So if you pile up water, you basically increase that pressure that basically allow the seawater to actually intrude into the aquifer. Exactly.
Mm-hmm.
So yeah. So you said earlier this week you were telling me about how you wanted to use a different type of material, right? Which, as you said, comes from so we say fossil fuel, but basically it comes from oil, right?
From oil, yeah.
From oil, it's interesting because oil also comes from biological processes, right? So, but you said you were interested in trying to find alternative material for construction.
Yeah, I thought early on when I was developing this process, I thought there was something that was kind of like futuristic in this very Miami way of like, instead of taking this organic seeming material out of the ground, I'm taking this like highly manufactured material out of the ground and using it to make something that seems natural. And to me it seemed more sustainable than using actual coral. And I'm really interested in these ideas in architecture about greenwashing and a lot of times the things that seem organic or positive.
What do you mean by greenwashing?
It's a term that's used. So I think there's a new like Amazon building that's going up that's covered in trees, but the amount of trees that it's covered in has like negligible impact, and also the cost and the carbon footprint of transporting these trees and all of this is like way, and the infrastructure required to hydrate these trees, it has a negative impact versus positive impact. So I'm really into the kind of like counter intuitive approach to these things. I think during the course of this show I've been reading a lot about the production of this material and kind of coming to the conclusion that I want my process to evolve a little bit. And I think it's a natural artistic process to kind of let materials evolve over time. I think this material, it has gotten. So when I think about material, I generally think about like where it's coming from, how it's produced, how long it's meant to last, and then what happens after that. So is it recyclable or is it thrown into the trash? And how to minimize waste in my studios. So when I was making this work, a lot of the pieces are all fall-off pieces from other pieces in the show. So there's nothing going in the trash. And I used a lot of recycled foam for the show, but a lot of it ultimately was bought in blocks. And this process for making EPS has been cleaned up over the years, and it's recyclable. It's 98% air, and it's the way that it's expanded now doesn't release greenhouse gases like it used to in the past. They use steam to do it, but ultimately it's from oil, and that's the part that
But it's very problematic for the climate.
Yes.
Yes, for sure.
Yeah. So now it's like, I mean, I think materials like this will evolve. There are a lot of articles about materials like EPS used in architecture because there isn't a replacement that is sustainable at scale. So growing even natural materials like wool or hemp for insulation in homes, that's kind of what I mean by greenwashing. It's done as a gesture, but if it has to be replaced like every however many years, which basically is, it adds a huge level of all of the work that's involved with doing that and throwing it out. Plus, if you try to apply it at scale, it would basically divert a bunch of agriculture land to just growing hemp for insulation. So there has to be a new material that kind of takes the place of this in the future. And I think, I want to evolve. I want to evolve quicker than that.
I mean, so what you're talking about is what often is referred as carbon footprint, right? Like how sustainable is your activity? How sustainable is your material? And I, as an individual person, I find it very, very hard to, discern what are sustainable practices, right? So some people actually study that very, very carefully, but, just like the choice between a plastic bag or a paper bag at the grocery store, right? Is it better to cut trees or is it better not to put plastic in the environment, right? So it's exactly the type of choice that we have to make in a conscious manner. And I agree with Claire, when she said that we're trying to be scientists like myself that are studying the environment are trying not to be too doom and gloom too much, right? Because it's not necessarily constructive to behave this way. But one thing I think is useful is to increase, climate literacy or ocean literacy, explaining to people why the ocean is important and explaining the repercussions of our actions. And so the corals are not very lucky because, with climate change, so not only we are, increasing the temperature of the ocean, of the waters, and so we are basically changing the environment, right? It's a bit as if, someone was deciding to, put up your AC in your home and you couldn't say anything about it. You wouldn't be very comfortable. Eventually, your plants are going to die in your home, and eventually you will die as well. So, all right, try not to be too doom and gloom. But so also because we put all that CO2 in the atmosphere, actually about a third of the CO2 that we put in the atmosphere through our activities, power plants, driving a car, etc., about a third of that actually dissolve in the ocean. And then another third is taken up by biology, by the plants, and the rest is basically left in the atmosphere. And this is why the atmosphere is warming up, because it's a greenhouse gas. So the part that is taken up by the ocean, it's a bit perverse, because what happens is that when that CO2 goes into the ocean, it can be used. It is used actually by the plants in the ocean through photosynthesis. That CO2 is being used by the plants to create organic matter, right? And this is actually what's happening inside, a coral. But it also creates an acid, and so carbonic acid, I think it's called. And that acid is basically changing the pH. What we call the pH is a measure of the acidity of a liquid. It's changing the pH of the ocean. And by changing the pH of the ocean, it's changing, the environment as well. It's making the bath of the coral reef, of the corals, basically more acidic. And then it prevents that type of animal and other animals to actually form that little shell, that little skeleton that constitute their core. So it's making the environment a lot more difficult for these animals to grow. So some corals, actually there's a scientist at the University of Miami in my school that has been studying the impact. So there's a lab and there's actually a video available you can see. And I think he's been interviewed also for an episode of Blue Planet 2 that should be available. His name is Chris Langdon. And he's been growing these little corals in the lab, and he's been putting them in a bath, and he's been changing the acidity of the water, and he's been changing the temperature, and he's been trying to identify which of the corals are going to be more resistant to changes in temperature and changes in acidity of the water. And so he has actually identified a couple of species that are more resilient, adaptable to these changing conditions because of climate change. Try to, what's the word, to actually try to plant back or like recolonize some coral reefs with these super corals that are actually able to sustain increased temperature and increased acidity in the water. But at the origin of everything, it's all the CO2 that we put in the atmosphere. So whatever we can do by changing the way we live or making conscious choices that we have, right? Because we have a choice to buy an electric car, we have a choice to change our way of life to actually limit our impact on the environment. It's all about stopping the release of CO2 in the atmosphere. I think that's the bottom line when it comes to the environment. So there are ways to do that could be positive and not necessarily negative.
So something that really struck me with this specific exhibition was thinking about the way in which we use strength. So Emmett, you're putting forward a new way to build. I think it's really fascinating. Are there any other tips that you can give us moving forward about how we can think about our environments and the way in which we build that doesn't necessarily extract from the earth, or alternative ways of thinking about the way in which we make things?
I mean, I think it's important to think about where things come from, and then where they end up. I mean, I think thinking about like this, where they come from, the production, and then ultimately what the goal is. And like even the electric vehicles, most cars are 50% plastic. So I think there's not much. I mean, I think you have to move things in the right direction. I think, but you have to be aware that the car is still 50% plastic, and still a lot of the energy that's powering the car is coming from coal-fired power plants. So I think it's like, I don't know who said this, but somebody said that the point of a lot of these conversations is to not get 10% of the people to change 100%, but to change 90% of the people 10%. And I think that's a lot. I mean, I think it's like evolution. In my work, I think it's like always, materials are always changing, and I got tired of like putting things in the dumpster, so I started trying to use more scraps of materials and just like trying to not go to Home Depot every time I needed material, but use things that were like accessible and in my periphery, and that's like a lot of the things I do. But I think it is about maybe we do need a radical shift, but I think little changes, or being conscious of all these things is important for long-term shifts.
Would you consider this greenwash in a sense, since it is tied to your phone?
I
know you're trying to. It's like you have the lesson is there, but then the material, like you haven't achieved your mission in a sense.
I think. Obviously it's my work, so I wouldn't like.
But as an artist, you're trying to achieve something. So you could maybe not necessarily concrete or something.
I think the difference is that I think I'm acknowledging what the material is, and I feel like when I made the work, I kind of weighed the pros and cons in this kind of way, where it's like, this was the better alternative, but it still needs improvement,
Yeah, this is working to start the story.
Yeah, and it kind of like, it started with working with scrap material and playing with it, so it was like recycled, and then it developed into this project, which ultimately I didn't have enough scrap. So then sitting with this work for a month, realizing that going forward I don't really want to approach it the same way. So I want to be like clear. I don't want to greenwash in the sense that I'm hiding what the material is. Like it's very clearly EPS, But I want to like open myself up to scrutiny, and I want people to have the conversation, because I think it is complex. It's like people use things like natural stone or wood and say it's green because it's a natural material, but there's a lot of implications. Like there were
I mean, in college, there's a million furniture design projects made out of pallet wood. Because it's like you're taking a pallet that had an industrial application and cutting it up and making something new, so you're recycling. But it's made from a really dense wood, so the projects wound up weighing, weighing a ton and not really being collapsible. So these projects, like these giant pallet wood tables, are being shipped all around the country as an example of being green. But the shipping and transporting of those objects, it's like you need a flatbed truck, and it's just, what's the real goal? So if you're using, even in that case, if you're using styrofoam, is that greener than using recycled wood? Or it's like, I want to open the conversation. A lot of my work isn't necessarily even about sustainability in a sense. Like a lot of my approach comes from more like DIY sensibility, where I want to do things. I want to use materials that are accessible to me, and work with what's kind of like available in my periphery. And I think as those things change, like as these materials change, that will change too.
Have you tried, like for instance this one, have you tried floating it in a pool or something?
That's what I'm going to try after the show's over. I really want to know.
Yeah.
I really want to
even know. But...
yeah, I want to know if it floats, but
Is there anything that we can do to ensure that the reefs that are still alive are post being looked after? I heard that, for example, some sandblocks are better for reefs than not, etc.
Don't step on it. Right? And yeah, I'm sorry, I'm going to go back to what I said earlier, like stop putting CO2 in the atmosphere as much as you can, because unfortunately, the bigger threat to the coral reefs are increasing temperature and increasing acidity. And so what happens is that, so you may have heard of like bleaching events of like corals, because this, when you see a coral full of color, it's basically like there's a symbiotic relationship between the animal, the coral, called pollen, and a plant, an algae, that basically lives inside the coral. And so the algae is able to, by photosynthesis, creating organic matter that is being used as food for the coral. And for some reason that I'm not entirely clear why, but when those animals, the polyp is stressed, it actually ejects the algae from its body, from its core. And when it does that, it basically loses its color, because the color comes from the algae. So it becomes white, and this is why we call that like a bleaching event. And so when it loses the algae inside, then it cannot feed itself. It doesn't have a source of food. And then it can recover if algae goes back inside, or if it let the algae come back inside. But otherwise it's going to die. So yeah, definitely protect as much. I'm wondering if I think people like in South Florida used to actually go and collect coral rock directly from live reef. So of course it's not allowed anymore. They used to use like dynamite the reef to extract the rocks and everything. So of course none of that is allowed anymore. But if you go to protected areas like John Pelican, out of Key Largo, just make sure that you step on it, because these are very fragile environments. As for the sunblock, I'm not sure, but maybe you're right. So yeah, pollution is a problem. When they were dredging the channel just outside of Port of Miami, it was problematic because they were dredging all that sediment that was basically covering the light and preventing the photosynthetic reaction to happen inside the coral. So any type of pollution that is going to murk the water is basically detrimental to the health of the coral and the coral reef. So these are the type of things really that we should be trying to do. So the city of Miami Beach, I learned, is banning the use of fertilizer for gardens during the rainy season, because all those fertilizers, when it rains, are basically washing up into the bay, and when they wash up into the bay, they create a bloom of algae again. The type of algae that is actually basically making the water murkier and preventing things such as oxygenation of the water. When you have all those algae, they are using up the oxygen in the bay, and this is why we had all these fish dying in the bay not so long ago, a couple of months ago. Sorry to do it blue again, but this is the type of things that you can do, like don't use fertilizer in Miami during the rainy season because everything is going to end up in the ocean, including those unhealthy environments. So I'm a firm believer that solutions to climate change really lie at the legislative level. Our politicians. So I try to vote for politicians that are actually going to take actions against climate change. But on the other hand, at the local level, yes, you do have some actions that you need to take, but that requires education, that requires literacy in ocean matters and climate matters. And the topic that you are talking about, sustainability, or even trying to understand the carbon footprint of construction, it's very difficult. So we need to do a lot more research in that aspect of our daily lives because we're not going to stop, going about doing, having our economic activities which are necessary for all of us. But we need to try to do it in a way that is going to be less impactful to the environment.
One of the things that kind of had with this show in particular that's kind of kept me up is thinking about the shift towards electric cars and away from fossil fuels because it is like kind of this counterintuitive idea, but with the increasing use of electric cars, it will lower the cost of fuel. So in developing countries, the price of gasoline will get so cheap, there will be a negative impact there in terms of emissions. And if it gets so cheap, people will use it for heating their homes or things like that. So I don't know the answer, but like with material like EPS or certain kinds of plastics, if there was a use for products made out of oil that could be a clean production process, then the value of oil would always have value as a building material. Building things that are meant to last forever and not biodegrade, like architecture. So if the process of using plastics could be cleaned up, then you wouldn't have a situation where the cost of oil gets so appealing to a huge amount of part of the globe.
Yeah, it's complicated. I think the production and consumption of oil is supposed to have peaked actually, and it's in decline. But what you're saying about what are we going to do with all that oil? And I think you're right. It's very complicated. I think one of the biggest plastic making factory is being built in Pennsylvania right now because they are actually anticipating that because it's not going to be used anymore for transportation and car, they need to do something with that oil, right? And it's with oil that you actually produce plastic. So producing plastic in itself is all right, but the thing is that we have a very bad relationship with plastic. Now, I always remember my grandmother back in France used to tell me that they didn't have the plastic bag and the sandwich bags that everybody used every day. It was not a very common thing, and it was something very precious that people would be like keeping and reusing. So that was a much healthier relationship with material, as being willing to reutilize it. But nowadays we produce so much plastic that it has become disposable, and as you all know, it has become a problem for the ocean. This is why also scientists like myself study ocean currents, because if we know what the currents are doing, we actually can try to figure out where the plastic is actually going and where it's going to end up. So there's a connection to that as well. But yeah, our relationship to materials and consumption should be reevaluated, I think.
I'm wondering what's next for you, Emmett?
Well, next on my agenda is our baby who's coming. He's doing 3.5 weeks, so I'm working on some projects in the studio, some just ongoing work, but mostly just devoting time to baby and And Claire's, yeah. So a lot of this work is moving across the street to a new space that'll be open like all the time, and it'll be more of a public lounge.
Awesome.
So yeah, so it'll be open 24 hours a day too.
Are you going to have any of those in your new home?
Yeah, so some of this I'm bringing back home, and then some of it's going over there. So.
And some of it is for sale, I'm sure. No?